a quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD is equal to AD plus BC. The first thing is we'll understand what is circumscribing a circle mean. See, I have a circle. The quadrilateral is covering this circle. How? Well, I can draw another quadrilateral, something like this. So this quadrilateral is cutting the circle. Okay. This quadrilateral is covering the circle, surrounding the circle, enclosing the circle. But ABCD quadrilateral is circumscribing the circle. What does it mean? It is touching the circle in such a way that it is covering the circle, and also it is not cutting the circle but just touching the circle. Are you getting it? So basically all of these points are point of contact and all of these lines are tangent to the circle. Okay. So now let's prove. Let's look at what we have to prove. AB plus CD is equal to AD plus BC. So we'll start off with, obviously this has to do something with the tangent and the external point. So we need to mention what are the external point. So what are the external points over here? The external points to the circle are AB, CD are the external point. Then what else is given? What are PQRS? PQRS are good point of contact of P is point of contact of AB, Q is BC, R is CD, and S is CK, respectively. Right? Now, what is that we have to prove? We have to prove that AB plus CD is equal to AD plus BC. Right? So now the proof. So proof is quite simple. AP is equal to PB. We'll call this as X. Okay. Oh, sorry, not PB. AS. My bad. AS. AP is equal to AS. Why? Because A is an external point, AP is a tangent, AS is a tangent. So the lengths are equal. That is, length of tangents drawn from an external point to a circle are equal. Right? Next, PB is equal to BQ. We'll call this as Y. And we'll call this as A. And we'll call this as B. So this is equal to Y. Then we have CQ is equal to CR is equal to A. And dr is equal to ds is equal to b. Right? So now let's look at what we have to prove. Whenever you have to prove anything, take the LHS and RHS and prove it separately. So from LHS of equation 1, we have AB plus CD. But what is AB? AB is nothing but made up of two lines, AP plus PB. Two line segment, AP plus PB, right? Correct. And CD is made up of, can you tell? Correct, CR plus RD. But what is AP as per the diagram? AP is X and PB is Y. CR is A and RD is B. This will call it as equation 2. Okay. So let's take now the RHS of 1. What is RHS made up of? AD plus BC. What is AD? AD is made up of AS plus SD, and BC is made up of BQ plus QC. So AS is X and B plus BQ is Y plus A. Can you look at equation 2 and 3? What can you tell? That they are equal, is it not? It's very clear they are equal. So we can tell from 2 and 3, we have LHS is equal to RHS, right? And we have proved what we require to prove. Okay, so the whole funda is that from an external point, the tangent length are equal. Give it, label it with some variable, and your job is done.